The GSD8 Digital DC Drives can be set up as a master follower so you can synchronize 2 or more motors. This is great for blending and batching feeders, chemical pumps where maybe you need to inject additives into wastewater at some percentage rate, web systems where you need tensioning, take-up, take-off, laminating 2 sheets pressed together, liquid gel forming, etc. There are lots of applications for a master follower pair. So let's do a quick example. This master is set up in rate mode, exactly like we did in the first video of this series, and we don't need to modify it, so I'm not going to repeat that here and just focus this video on the follower. Suppose we have some kind of feeder system or blending system where we need one motor pumping at one feed rate and another motor pumping at some ratio of that rate. The key point is, no matter how fast the main feeder system's running, we want the second system to keep up so a constant percentage or ratio mix is maintained. This is the wiring we did for the rate mode demo in a previous video. That'll be our master, and it requires no changes. To add a follower, we do an almost identical setup. You add a motor, attach an encoder, or whatever sensor you're using, and wire the sensor to the drive. The only difference is we're going to take the sensor signal from the master and wire it to S2 on the follower. I also wired the inhibit switch to the follower so I can shut them both down at the same time. That's it for the wiring. I chose to use a 5 amp drive and a 1 horsepower motor for the follower just to show you that you can mix and match these things. Of course, you would want to choose the type and size devices that you need for your application. These are the parameters we'll need for the follower drive. Let's do a factory reset to make sure we're starting at the same place. Hold the Enter key down to get into parameter mode, go to parameter 95, enter a 5, and hit Enter. And press the up arrow to confirm, and we're now at the factory default state. Okay, we want this drive to be in follower mode, so I'll drop back into parameter entry, scroll to parameter 10, and enter a 3 for follower mode. Enter to accept. For the display mode in parameter 12, let's start with it in leader speed mode, which is a 3. That'll show us the master's encoder value so we know we're getting the correct sensor signal. Once we see that's working, we'll change this to show the follower speed as a ratio of the master in percent, so we can easily dial up any ratio we want. S2 defaults to jog signal, so we need to change that to a 1 so the drive can use S2 as a follower signal. Let's go to parameter 37 and make sure it's set to the 20 pulses per revolution that our encoder is generating. It is, so we're good there. Well, that's it for parameter entry. But don't forget, mode changes require a power cycle. So I'll power down, wait a couple seconds, and then power back up. Let's try it. I'll disable the inhibit, and we see the master ramp up to speed. But the follower isn't doing anything. We see in the follower display that it is getting the pulses from the master, so what's going on? Well, we haven't told the follower what ratio to use. Now that we know we're getting the master's pulses, let's go back into the parameter entry mode, go to parameter 12, and change the display to show us the percent speed that we want the follower to match the master at by entering a 1. And I'll scroll to parameter 0 and hit enter to get out of parameter entry mode. Ah, look. The follower is being told to run at 0% of the master speed. Let's change that to match the master speed, or go to 100% of the master speed. Now there's an implied decimal point here, so we need to go to 1,000. You can see the follower motor starting to rotate as I scroll up to 100%. Well, it's moving, but is it really tracking? I'll bring up a strobe light and dial it up to this RPM, and sure enough, we see the follower tracking the master. Cool. If I change the percentage, we see the follower losing track of the master. If I go back to 100%, it locks in. Perfect. Okay, I'm going to go back into the parameter mode one more time and change the display mode in parameter 12 to a 2. This will show us the real-time tach value of this drive's motor, but it allows us to flip over to the percent value and adjust that. And I'll scroll down to 0 to exit. Okay, the master's at 1300 RPM, which we see in both displays. So let's take the follower down to 50% of the master speed. The display reverts to tach mode, and we see that the follower motor is now running at 650 RPM, exactly what we expect. And since it's an even multiple, the strobe shows us that both motors are still in sync. Cool. And really all we did was connect the two drives via one wire and change a couple parameters in the follower, and we were up and running. Not bad at all. Now, wouldn't it be cool if you could do this with any DC drive? Even an analog drive that's normally controlled with an analog speed pot and doesn't have feedback. Well, guess what? The GSD8 series of DC motor controllers has a digital speed pot that does exactly that. It replaces the analog potentiometer with a digital one and adds a feedback path, which means you can run the analog DC motor controller both open loop or closed loop. And does this have to be a DC motor controller? Nope. You can use it with any controller that requires a voltage reference in. Join me in the next video where we'll do a quick example of how to use that digital pot. Click here to see all of the videos in this series. Click here to learn about Automation Direct's free award-winning support options, and click here to subscribe to our YouTube channel so you'll be notified when we publish new automation videos.